Hi everyone, let's continue. Last time we finished example 4. So let's look at the following. Every homogeneous system with more variables than equations has infinitely many solutions. So we call example 4, this is a homogeneous system. And we can see there are 2 equations and 3 unknowns. So we have more variables than equations. And then you can see at the end, after we get the echelon form, because there are 2 equations, so we can only have 2 leading coefficients. And then there is a column with no leading coefficients, leading entries. So we can see the variable c is 3. So that's why we have infinitely many solutions. Okay, so in general, this is true. Every homogeneous linear system with more variables than equations has infinitely many solutions. We call that a single hyperplane through the origin is a subspace of Rn. So we showed that last time, okay? i.e., the set contains all the vectors u, such as c1, u1 plus c2, u2, cn, un equals 0. So this is a hyperplane passing through the origin, and it is a subspace of Rn. And for example, this set is a subspace of R4. So this is a single homogeneous equation. Okay, next, the null space of A, which is also called the solution space of A, is the intersections of hyperplanes through the origin in Rn. It is also a system of m homogeneous equations. It is the set of all u such that AU equals 0, where A is the m by n matrix. Okay, so it's the intersection of m hyperplanes. So each equation represents a hyperplane. So that's why the solution of this linear system corresponds to the intersections of those n hyperplanes. Okay, so and the solutions form a solution space, and we also call the null space. Okay, so we want to prove the null space of A is a subspace of Rn. Okay, what is the null space again? It is U in Rn such that A times U equal to 0 vector. We want to show this is a subspace, so we want to show it satisfies those 3 conditions. First, non-empty. Let's check the 0 vector. Well, A times the 0 vector is 0 vector. Yay! So 0 vector is in the null space. Let's call it W. Second, we want to check close under addition. So suppose U and V is in W, and we want to show U plus V is in W. Okay, and because U is in W, it means AU is 0. And because V is in W, so AV is 0. So we want to show whether A plus V is in W. So we want to find out what is A add on the vector U plus V. Well, but because matrix multiplication is distributive, so we can distribute. So this is AU plus AV. AU is 0, AV is 0, so 0 plus 0 is 0. That's okay. Or hence, because A times U plus V is 0, so U plus V is in W. Okay, so this is closed under addition. Next, closed under scalar multiplication. So suppose U is in W, and let's say K is any real numbers. Okay, then we want to show K times U is in W. Alright, so because U is in W, we have a U is 0. Alright, and in order to show whether KU is in W, so we want to figure out what is A add on the vector KU. Well, because multiplication is associative, right? So we can multiply the AK first. But because K is a scalar, a matrix times K is just like all the entries multiplied by K. So, and then we know multiplication of numbers is commutative. So that's why it equals K times A. And then multiplications of vectors, a matrix is associative, so then we can have AU. And what is AU? 0. K times 0 vector is also 0 vector. So we have so we have KU is in W. So therefore that's because it satisfies the three conditions, so W is a subspace of Rn. Okay. Alright, good. Let's continue. So example 5. What is the null space of A? Okay, so null space is the solution space. We want to express it in terms of a space. So now let's see how we do it. But first of all, we want to find the solution. Okay, so here we have a matrix A. We can use Gaussian elimination to find the solution, and there is another shorter way we can know whether it has a unique solution is to compute the determinant. Okay, so we want to solve a U equals 0, but maybe it's easier to compute the determinant first. Okay, because if determinant of A is not 0, then we get a trivial solution. And if determinant of A is 0, then we get infinitely many solutions. Okay, so and in this case, we need the Gaussian elimination. Okay, to find what is the solution, what are the solutions. Okay, so now let's see. Oh, let me change back to orange color. So the determinant is, okay, so we use absolute value to denote. Okay, what I want to do, I usually pick the a row or a column with a lot of zeros. So in this case, let me pick the second row. Okay, and you can pick any row or any column to do the cofactor expansion. Okay, remember the one entry is positive and then it alternates. So that's why we have -2 times the submatrix by deleting the second row and the first column. And then plus 0 times whatever is 0 minus 2. Okay, and then times the determinants of the submatrix by deleting the second row and the third column. So 1 minus 1, 1, 2. Alright. So cross multiply -4 minus 8 2 minus 1, so 2 plus 1. -2, this is -12. -2 times 3 is 6. Okay. This is 24 minus 6, 18. Alright. Let's double check our work, okay? So we have, oh, you know the mistake I make? I forgot the minus. Yeah, sometimes it's very important to check our work. So then this become minus, so then it become positive. So let's see what happened. Then it become minus 4, and then this become 8, and it become 2. Yes, so this is the mistake. So sometimes one minus can change a lot. Okay, so be careful, check your work, especially when you finish your exams. Save some time to check your work. Okay, and also show more work, because if you show more work and then I know how you do it, you understand how to do it, then you get partial credits. Okay, so okay, what's next? Determinant is 2. Well, oh, so it's not 0. Then we know the solution is trivial. So the solution, okay, we just get the solution is the trivial. Then what is the solution space? Okay, so solution space, the no space, remember, is u such that au equal to 0. But because in this case we only have the trivial vector, so this is only the trivial vector. It's the sets. We have only one trivial vector, the 0 vector. Okay, let's continue. So example 6. We have this A. Okay. So I hope you can pause the video and try to work on it. Okay, have you finished? Let's check our work together. Determinants of A is, okay, let's use the first row, plus minus plus. So 1 times 0, 2, 2, 3. Minus -1 become plus 1. And then we have 2, 2, 1, 3, and then plus 0. Okay? Now, cross multiply 0 minus 4. 6 minus 2. Ooh, do you see what happened? Is 0. So we have infinitely many solutions. Okay, now let's solve. Gaussian eliminations. We put A adjoined. This is A adjoined the 0 vector. And 1, minus 1, 0, 2, 0, 2, 1, 2, 3. First step, make the 1 entry 1, and it is already 1. Good. Okay, so now let's continue. We can use it to cue the entries below it. So minus 2 row 1, add to row 2, minus row 1, add to row 3. Okay, 1, minus 1, 0, 0, stay here. 2 minus 2, 0. 0 minus 2 times -1, 0 plus 2, 2. 2 minus 0, 2. And 1 minus 1, 0. 2 minus -1, 2 plus 1, 3. 3 minus 0, 3. Alright. Can you see second row has the factor 2? And the third row has the factor 3. Okay. So what do we have? 0, 1, 1, 0, 0, 1, 1, 0. Now do you see the second row and the third row are the same? So we can cancel the third row by using minus row 2, add to row 3. Okay, good. Now we have the stair shape. So this is the action form. And the first column corresponds to the coefficients of, let's say x1, right? x1, x2, x3, and this is the right-hand side. Okay. And the first row we have leading coefficient, and second row we have leading coefficient, but then the third column has no leading coefficient, so x3 is free variable. So then we let x3 be t. Alright. And now second row tells us that x2 plus x3 is 0. So x2 is minus x3, so minus t. x1, first row, x1 minus x2 is 0, so x1 is x2, also minus t. Okay, so now x is x1, x2, x3, which is x1 is minus t, and t. Okay, so what we can also factor out t, then we have minus 1, 1. Right? This is one parameter family. So what is the no space? So no space is a space. Okay, so you want to put it as this is a set contains all the vectors of this form such that t is any real numbers. So this is the way how we express it in terms of a set. So it is a set generated by the vector minus 1, 1. Okay, so this is the no space. So far, so good, everyone. Do you have the same answer? Alright, let's continue. Example 7. Solve the system. Express your solution in the form of SU plus TV, a linear combination of U and B. Okay, so this is 3 equations in R4, right? So because we have more variables than the equations, we know there must be infinitely many solutions. Okay, let's solve for it. Alright, so let's see. Coefficients of the first equation, 1 minus 4, 1 minus 4, 0. Second row, 1, 2, 1, 8, 0. Third row, 1, 1, 1, 6, 0. First step, make the 1, 1 entry 1, and it is already 1, so use it to kill the entries below it. Minus R1 plus R2 minus R1 plus R3. Okay, now let's see what happened. 1 minus 4, 1 minus 4 is 0. 1 minus 1 is 0. 2 minus negative 4. 2 plus 4 is 6. 1 minus 1 is 0. 8 minus negative 4. 8 plus 4, 12. 1 minus 1 is 0. 1 minus negative 4. 1 plus 4, 5. 1 minus 1 is 0. 6 minus negative 4, which is 6 plus 4, 10. Can you see the second row has the factor 6? Let's divide it by 6. Third row has factor 5. Let's divide it by 5. 1 minus 4, 1 minus 4, 0, 0, 1, 0, 2, 0, 0, 1, 0, 2, 0. Oh, can you see the second row and the third row are the same? So we can cancel the third row by doing minus row 2 add to row 3. 1 minus 4, 1 minus 4, 0, 0, 1, 0, 2, 0, and then 0, 0, 0, 0. Okay, now can you see the stair shape? Okay, this is the leading coefficient, this is the leading coefficient, and the first column corresponds to the coefficient of x1, x2, x3, x4. This is the right hand side. Can you see x3, x4? Those columns have no leading entries. So x3, x4 are free, okay? Alright, so they are free, then we let x3 be s, x4 be t. Okay, second row tells us that x2 plus 2x4 equals 0. So x2 equals minus 2x4, x4 is t, so minus 2t. And then first row tells us that x1 minus 4x 2 plus x3 minus 4x4 is 0. So x1. So move the rest to the other side. We flip the sign. So positive 4x2, negative x3, positive 4x4. Okay, 4x2. 4 times negative 2, negative 8t. x3s, x4t. So then we have minus 4t minus s. Alright, almost there. So what is x? So x is x1, x2, x3, x4, right? x1 is minus 4t minus s. x2 is minus 2t. x3 is s. x4t. Okay, so the problem asks us to express the solution in terms of SU plus TV. Okay, how do we do it? Now, look at this. Do you see the coefficients of T? So you can actually separate them, right? You look at the coefficient of T and coefficient of S. Here, there's no S. You can imagine it's like times 0S. And here has no t, you can think about it's like 0 times t. And here has no s, you can think of 0 times s. So now, after you separate them, you can pull out the t. Coefficient of t is minus 4, minus 2, 0, 1. Coefficient of s is minus 1, 0, 1, 0. And, so we say SU. So this guy is U plus TV. So this guy is V. Okay? So that's why you can see U is minus 1, 0, 1, 0. And V is minus 4, minus 2, 0, 1. And then we can express our solutions as a linear combinations of U and V. Okay? So that finished the problem. Sometimes you need to read the problem carefully. So if the problem asks you to find the null space, what do? Well, the null space, which is the solution space, is a space. So it is a set. So you can put U minus 4 minus 2, 0, 1 as minus 1, 0, 1, 0. Such that S and T are real numbers. Okay, so this is a set generated by those two vectors, U and V. Okay, and it is a subspace of R4. Okay, so this guy is a subspace of R4. Okay, so read the problem, read the questions carefully, answer the questions in their way. So if they ask you no space, then answer the no space. If they ask you to express your solution in this form, then you express it in this form. Okay, if they want you to just solve the system, probably then you can stop here and just say S and T are real numbers, so we get a 2-parameter family. Okay, so and you can see when we talk about the dimension, we can talk about more. So right, dimension, you can see dimension of this null space. Because it's generated by two vectors, so the dimension of this null space is 2. And our previous example, what is the dimension of the null space? Any guess? 1, because it's generated by one vector. And in here, the null space is the 0 vector, so what's the dimension? Of course, 0. Okay, good. So now we have finished 4.2. And so now we have finished everything that we need in chapter 3 and chapter 4. If you have any questions, feel free to ask me. Okay? Have a nice day. Bye-bye.